Antidiuretic hormone, or ADH, also known as vasopressin, is a hormone that plays a crucial role in water conservation in the body. ADH is produced in the hypothalamus and released by the posterior pituitary gland. It primarily targets the collecting ducts in the kidneys. Osmoreceptors in the hypothalamus detect changes in blood osmolarity, which is a measure of the concentration of solutes in the blood. When blood osmolarity increases, indicating dehydration, there's a higher concentration of solutes relative to water in the blood. This triggers the release of ADH from the posterior pituitary gland into the bloodstream. ADH targets the collecting ducts in the kidneys, where it binds to receptors on the tubule cells. When ADH binds to these receptors, it causes aquaporin water channels to insert into the cell membrane, making the collecting ducts more permeable to water. This increased permeability allows water to be reabsorbed from the collecting duct back into the bloodstream, following the osmotic gradient. When blood osmolarity is high, ADH release increases, leading to more water reabsorption and concentrated urine. This helps decrease blood osmolarity back to normal levels. Conversely, when blood osmolarity is low, ADH secretion is inhibited, resulting in less water reabsorption and more dilute urine. Osmoregulation is the physiological process of maintaining proper water and solute balance within the body's fluids. This delicate balance, known as homeostasis, ensures that cells function optimally by preventing excess water gain or loss. Multiple biological systems work together to maintain this critical equilibrium. Osmoregulation involves several key components working in harmony. The three principal components are the kidneys, hypothalamus, and thirst mechanism. The hypothalamus connects these systems, monitoring blood osmolarity and triggering responses in both the kidneys and thirst centers. The kidneys are vital organs for osmoregulation. Each kidney contains over 1 million nephrons, which are the functional units responsible for filtering blood. The process begins with filtration at the glomerulus, where water and small solutes enter the renal tubules. As fluid travels through the tubules, selective reabsorption of water and essential solutes occurs. Antidiuretic hormone, ADH, plays a crucial role in this process by regulating water reabsorption. When ADH levels increase, more water is reabsorbed, resulting in more concentrated urine. When osmoregulation fails, serious disorders can occur. Diabetes insipidus results from either insufficient ADH production or kidney resistance to ADH. This condition causes excessive urination, up to 20 liters per day, along with extreme thirst. Without adequate water intake, rapid dehydration can occur, leading to electrolyte imbalances. The opposite condition, syndrome of inappropriate ADH, occurs when too much ADH is released. This leads to excessive water retention and reduced urination. The retained water dilutes sodium levels in the blood, causing hyponatremia. Severe cases can lead to dangerous neurological symptoms, including confusion, seizures, and even coma. Proper osmoregulation is essential for cellular function. It maintains the optimal fluid environment for cells to operate. In a dehydrated state, cells shrink as water moves out by osmosis, disrupting cellular processes and potentially leading to cell death. Conversely, when too much water enters cells, they can swell and potentially burst, a process called cytolysis, which is equally harmful. When osmoregulation functions properly, cells maintain their optimal volume and internal environment, enabling all cellular processes to function efficiently.